Hi, welcome to exceloptim.com. My name is Pedro and today we're going to talk about using Docker to run Biogeme. And that's because Biogeme doesn't really work properly on Windows. So this is an alternative to the virtual machine workflow that I have talked about before for Windows users. Of course, this can be used in any system that supports Docker, but the example here is using Windows, which is, I guess, is going to be most of the users. Before we go to the actual use of Docker, there's just one small point here that I would like to point out to you guys. First of all, you need to install Docker, go to docker.com, register, download it. It has a couple steps. It's pretty straightforward, and I'm going to leave a link in the description below to a pretty good tutorial from Docker how to do that on Windows. You're going to have to activate Hyper-V on your computer, and Docker is going to prompt you to do that. But after that, where's nobody really written, is that if you're concerned about using Biogeme, you're probably concerned about performance. You want to use all the resources possible from your computer. So in the tray here, if you go properties, which is in my other screen, you can't see. If you go to Docker properties, you get to this screen here. And of course, stores in general. If you go to advanced, you can define how much resources Docker is going to use. And I'm going to give it, say, I don't know, up to 7 threads and roughly 16 gigabytes, a little less than 16. It doesn't really matter. I'll give just a lot of resources. And say, my disk image, my Docker disk images, we're really not going to use this. We need a couple gigabytes there for our Biogeme image. So that's all the setup we need. This is the setup that is in the installation, the Hyper-V activation, which is you're gonna be prompted to do, and then just this quick setup. Pretty nice and easy. So now let's go to the actual use of this. Now, let's start it. So, on GitHub, and the link is below to the repository, you're gonna find this Docker file, which is what really has all the information to Docker Docker to build our Biogeme machine, if you will. So what I already did was I downloaded this repository to my machine. This is a machine that I never used Biogeme before, and I cloned this repository here. But if you could just download, go on GitHub there and just download the repository if you want to. So what we're going to do here, you're going to open a command prompt here. Any command prompt on Windows will do. I'm going to use git bash here because it's the one that is easier for me to access. And let's do it. If you look in Docker, there are many ways to do this setup. One of the things you can do is to give it a machine a name. So, and I'm gonna call my machine Biogeme. So what I'm telling Biogeme, Docker here is, Docker, hey, build -t is, and call this machine Biogeme in my local system. And the dot is just referring to our folder. Since we are working on this folder, or f Biogeme here, where my Docker file is, what this is gonna do is in the local folder, gonna look for a Docker file and try to build it and call it, and it's going to name it Biogeme. And the name is important because we're going to refer to this name later when we actually want to run scripts. If I press enter here and I run this script, this is first is going to download from the internet the Python 3.6 screen box or Docker image, and it's gonna install everything else I need, which in this case is just Biogeme. So if we open the Docker file here for an instant, we can edit with Notepad here. It is, we say, you know what, let's use Python, this box, which is a standard box or Docker image on the Docker repository, and do this. Download my Biogeme 2.6a, which is the latest one as of today from the Biogeme website. Unpack it, configure, and run, make and install, so compile it, and then just delete the folder where we unpacked it. That's all. That's all it's doing. And here my internet is not that fast at home, so it's still downloading. I will come back with you when it is a little farther ahead in this process. So the download finished. The machine is almost ready in terms of download. And now it's downloading Biogeme, and now it's going to start compiling it. And this is something that, depending on how powerful your machine is, might take a really long time. It is a lot of C code and C++ code to compile. So, however, I forgot to mention, and it's important that this will only need to be done once. The download, the setup, once it's done, the machine will be in your system. There will be a local copy in your system ready to go. So I'm gonna stop here again and let it run until the end. Let's go to the example. A quick example here. If you download or clone the tutorial repo from GitHub, you're gonna find the following. There's the Docker file, little README, and a script. There are all these in the root folder that I'm gonna go over in a minute. And inside the Biogeme examples folder, there's all the Python Biogeme examples that Birler has on his website with the dataset. So all of these guys here. So what this estimate all examples does is the following. The hypothesis I'm taking here is, hey, we want to estimate all these models. Right? We want to run all these Python Biogeme scripts. What we would do, we would, get the folder where all those scripts are, which is this root here, wherever we are, plus Biogeme examples. Find all the .py files and build folders that are this folder here, the Biogeme examples, plus just the name of the file, so 01 logit, for example, 01 logit _ simul, and move the script there and run and build the Docker command, which is this guy here, docker run, sharing the folder, starting at the folder, and for this Docker image, Python Biogeme, name of the script, and the Swiss Metro dataset, which is going to be in its Python, in its parent folder. And I would append that to a batch job, list and just write them to the list, to the list later. So let's run this script and see what happens. I'm gonna run here from Python, PyCharm, but you could run from anywhere you would like. And let's go for it. Let's run from here, for example. I'm gonna run Iran. There you go. You created, and if you go there, you see that everything moved into those folders. And it created this docker underscore batch here. Let's open this file and see what it has. So it's there, this guy. So what it did was docker run. Let's look at only one line, and they are all really equivalent. Docker run -v, which is one of the Docker options. You can look at the documentation if you'd like. Sharing this folder from our host, from our Windows, into temp model run mr inside Docker, and this is totally up to you what you would like. And let's start the Docker image in that folder. We're going to start a tmipmr 01 logit biogeme, and we're going to run python biogeme 01 logit and Swiss metro in its parent folder. Let's run this bat file and see what happens. There you go. It's running. It already ran the first one, which is super fast. It's running the simulation, which is the second one. Running the third, it's ran the weight, 3 scale, super fast, running all of them. And let's wait until it gets to something a little bit, oh, this one is a little beefier. So I put 7 threads, I made 7 threads available to Biogeme, to Docker, which in a 8-thread machine, 4-core 8-thread, should be 87% of CPU. Because of Windows, the way Docker on Windows is built, it will never really reach that. If you run multiple instances of Docker at the same time, you will, but on a single Docker image, a single model estimation, you are not gonna use all the CPU power you gave. So what I do to get around this when I'm making really big batches of estimation jobs to run overnight or over the weekend, I will have 3 or 4 batch files of approximately the same size, just running in parallel, which makes they will be fighting, each instance will be fighting for CPU, but in the end they end up using all the threads. It's not the most elegant way, but it is definitely a way to get around this lower performance you would find. However, this is still much better than native Python Biogeme, and in the end you can batch all these jobs and leave them running overnight and get results in the morning. In this case, we have 29 jobs batched here to look later. Well, now that Biogeme ran, all we need is to check if the outputs are there. So let's go. Yep, the log is there. You ran. All the outputs are there as it should. Where's the HTML? It's here. Where the standard output. Look at, there you go. And for all models we ran, the files are there. So in a single run, we can get all these outputs. So yeah, that's it. Thank you. If you have any problems, as usual, just shoot me an email or comment on this video or comment on the blog, and let's keep the conversation going. Thank you.